All righty, join with computer. Why don't I have this showing up here? Let's see, where's the video? There it is. Okay, there's the video. Let's see. There we go. Okay, so I got a request for logs from Alicia, and Tram wanted some sine, arc, cosine stuff. So I'm just going to do 3 quick problems here. I'm going to start with practicing using the exponents. Once we get an answer over here, I'm going to write it in log form and then see if you can figure out how you would go back to get those answers. I think that might be helpful. All right, so I know you asked for initially logarithmic questions, but I think practicing the operations here is going to be very useful in the inverse thought process. All right, so you're going to pause the video on every single problem that I do. I'm not. I'm just going to go right through it. 10 minutes from now, I'm going to be done. And but you get your practice in by pausing the video. So each time you try one of these, pause, and then each time we continue our work, pause, and I'm just going to work through. All right, so I see 36 to the 1/2. That means square root. And the square root of 36 is 6. And a minus sign means reciprocate. So this is 1/6. Okay, and when we do the logarithms, we'll see how we can come back to that answer. Okay, what do I see here? I see a fraction, so I'm going to reciprocate first. That's going to make this the number 8. Then I'm going to take the cube root of 8, which is 2, and 2 to the 4 is 16. Okay, and now over here, I see another reciprocation, but I'll do that last. I see cube root. Cube root of 125 is 5. 5 to the negative 2 is 1/25. It's 1/5 squared. So I know the squaring is in the denominator. And that's one way to look at that. So I'll write 1/25 here. All right, so 1/6 is the quantity that comes from this calculation, and that's the base. So the logarithmic equation would have been log base 36, 1/6. And then the question is, what do I put on top of a 36 to get a 1/6? Same base, right? So 36 is 6 squared. To what exponent gives us 6 to the negative 1? There's our 2x equals negative 1. There's our x equals negative 1/2, which is what we used over here. Okay, so that's the connection to that problem. Now this, if I'm going to write it in logarithmic form, this is my answer, right? This is my exponent. Logarithms are going to find this value. So I'm going to write a logarithm that takes the answer and looks at the base and says, how do you turn this into that? We know the answer is this. We know we put this exponent on top of this base to get that. So now the question is, how do I show it? All right, because of space, I'll write up this time. So what's the first line of work? Well, understanding the command, the value of the exponent that you put on top of 1/8 to get 16. So the value of the exponent that you put on top of 1/8 to get 16, immediately I can see I need a reciprocation. I need to flip this fraction. But we're going to look at common base. Looks like the common base is a base 2. 1/8 is 2 to the negative 3. I want to know what x gets me 2 to the 4. My rules of exponents are multiplication. I'm sorry, the exponent 4, I lost my train of thought. Okay, and so what's the x? Minus 4/3. Oh yeah, we said minus 4/3 on top of 1/8 gets us 16. And you can pause the video here. You can see how you're going to write this as a log. Okay, see how you're going to write that as a log. And then you're going to see if you can do the logarithmic process to come back to an answer of minus 2/3. Okay, so let me just get some space here, the final frontier. Yeah, some voyages, oh, forget it. So the question is, oh, I erased the answer, it was 1/25, right? Okay, so logarithmic means we're going to find the log that gets an answer of 1/25 coming from a base of 125, and we know our answer is negative 2/3. Now, the information there is no different than the information here, except that from exponent to quantity is now quantity to exponent. Okay? So that's just saying it backwards. So instead of going from the exponent to the quantity, we're going to go from the quantity to the exponent. Okay, so let's pretend we didn't know that answer. You pause the video, go find it. Well, I know I've got 125 to the x, and I want that to equal 1 over 25. Oh, that's 5 to the 3x. I think I can write it that way. The repetition here is friendly, and I believe that's 5 to the negative 2. Repetition is friendly. So therefore, 3x equals negative 2. Looks like x equals minus 2/3. Oh, yes, that's what we wanted. Okay, so I hope that's the kind of practice you wanted, Alicia. All right. Now, we'll do these types of arc cosine problems. All right, let's make sure you can see everything. Yes, you can. All right, so arc sine is the right side of the circle. And there's a road I can take to draw any triangles. I can either go up 90 degrees or I can go down. And instead of writing down, I'm going to put a minus sign. All right, so these types of answers, these types of drawings are drawn on the right side of the circle. But I don't see numbers like 1/2 and √3/2 and negative √2. I don't see numbers that are famous ratio angles, 30, 45, 60, right? So I don't think this fits drawing it like that. But I do know that my triangle's got to be drawn here because it's negative. So what I like to do is go back to standard definition, opposite over hypotenuse. So I get the heck out of the unit circle, but I know where I'm drawing. Okay, and I don't need to know that angle. We'll call it angle A, because what I'm really looking for is the cosine of that angle. And on a calculator, looks to me like it would be near negative 20 degrees, negative 22 degrees. That's my guess, because I know minus 1/2 is 30 degrees, and this is smaller. Okay, so it's less traveling distance than that. But I don't need to know what it is to answer this, because I know that's the square root of 40. 49 minus 9. And now I know the answer, which I'll write up here. Cosine, √40/7. Okay. Same type of problem over here. Same type of problem, except the drawing's going elsewhere. All right. This is an arc cosine. Cosine inverse is how you would read this. This is the cosine inverse of negative 5/8. And the arc cosine is the top half of the circle, terrible circle, half circle, 0 degrees to 180. Right, so I know this is drawn somewhere up in here, but I'm not going to use the unit circle because I don't have a famous ratio. But I am going to draw it either the first or the second quadrant. Looks like that's a pretty good drawing. Right, cosine adjacent over hypotenuse. My angle again, more than 100, more than 90. You know, my angle might be around 125 degrees. So this is a cosine of some angle, right? I'm sorry, some angle. This thing becomes the angle, which we're not going to put into a calculator to find. And I'm finding the tangent of that angle, the tangent of that angle. I don't need to go to a calculator. 64 minus 25, I hope that's 39, 49, 50. I think it's 39, I hope. Brain is a little tired. I hope that's right. All right, let me check it, 39. Yeah, okay. So what's the tangent? Opposite over adjacent. So I put my answer over here, √39 over negative 5, but I would never leave the negative in the denominator. I would never leave it there because it doesn't read well. I would shift it to the numerator, minus √39/5. Maybe saying minus √39 divided by 5 is clearer. Okay, so hope that helped, Tramp. We're going to be doing them all year long. I have a lot of faith in you. I think you're going to be getting those right every time by midterm and the end of the term. All right, and we'll do it long enough that hopefully you don't forget it, okay, in case you have to keep working with it. All right, so that's it for the video for you folks. Got to make one for my other class now, so I'm going to upload this and then throw it in the trash. No, I was only kidding.